33. So at this point, you guys all agreed by checking those values to see the law of sine stuff to get two triangles. Now, if you guys were gone, when we did this, what happens here with the law of sines is that you guys have seen law of sines from last year, where everything always worked nice and cleanly. Whether or not you had to solve for an angle or solve for a side, everything worked out cleanly. What happens now is that you have two types of the angles. You've got an acute angle or an obtuse angle that you're working with. Whenever you have an obtuse angle, it's very easy to see what's going on. In an obtuse angle, if you're given that, if the side opposite your given obtuse angle is shorter than the other side, the triangle can't occur. Because the rules for triangles state that the largest angle has the largest side, smallest angle, smallest side, and so on. So if you're given a larger angle, which is obtuse, you know you can't have any other angle that's bigger than that. That means that the side opposite it has to be the longest length. That's why no triangle occurs. If you have an obtuse angle and the side opposite is bigger than the other one, it works out just fine. Now the weirdness begins when you have acute. When you have the acute angles, you have to go through your trials. So we draw out the diagram. We have A, B, C, 16, 92, 32, a little A over here. Since 16 is acute, we start checking it. And what we're doing here is we're using the sine of the given angle times the side not opposite it, times the other side. And you're checking to see, is that smaller than the side opposite the given, and is it smaller than the other side? When you do that arithmetic part, you get, I think it's like 25 and change for the sine part. So this was like 25 point something, which is smaller than 32, which is smaller than 92. That's why it means we have two triangles. And that's where we get the two triangles. So here's what happens. You set up and solve for what angle can you find now? B. You set up and solve for B like you would normally, and then you worry about changing it into two problems. So when you set up for B, we take the sine of 16 is to 32 as the sine of B is to 92. So you wind up with the inverse sine of 92 sine 16 over 32 to give you that angle. And with any luck, when you put that in the calculator, you get 52.41. If you're getting error, you're doing it wrong.
I'm not getting error.
Well, here's why. Are you in degree mode?
Yeah.
Okay. Now, when you type it in, do the following. What was it? 92 sine 16, hit enter. Divided by 32, hit enter. Second sign of your answer, and there you go. Got that time. Don't try and type it all in at once. That's why. If you're getting errors all the time, break it down in smaller parts. It's that easy. Okay. So now you have angle B is at 52.41. The way that these work now, in order to show that you can have two triangles, is now based off what we call the unit circle. We kind of talked a little bit about this before. In past years, when we've done this section, we've already gone through the unit circle, so it's a little bit easier to understand why the ambiguous case occurs. Now, if I put this up on the board, you guys are just thinking four quadrants, right? If you've got x, y, they're both positive, negative, positive, negative, negative, and positive, negative. Do you agree? What's going to happen now with the unit circle is the following. Instead of being the ordered pairs of x and y, it becomes ordered pairs of cosine, sine. So now that means that if you walk through the four quadrants the exact same way as you would have with the x's and y's, means cosine's negative in the second quadrant, sine is positive. They're both negative in the third. Cosine's positive in the fourth, but sine is negative. What that means is the following. If I take a 30-degree angle and I find the sine value of 30 degrees, it's going to give me a positive answer. Do you agree? That also means if I take what's called the reference angle to that, I'm bouncing up from 180 degrees. The reference angle then would be 150. You see what I'm doing here? Those two angles have the same, they're on the same horizontal line. If you're on the same horizontal line, what of the ordered pairs is shared? Your y value. That means that the sine here and the sine here is the same. That's how this is used. This is why you can get two different angles that have the exact same sine value. That's how you can get two triangles. Does that make a little bit of sense?
Yeah.
As we get into more of this reference angle stuff next week, it really comes into play. And those of you guys that have heard about the unit circle, if you know your basic angles in the unit circle, every one of them is just mirrored by working through rectangles. How you staying on horizontal lines, vertical lines. Horizontal lines share the same what? Vertical lines share the same. So you're just changing signs as you go through, okay? It's really not as funky as this looks, all right? It's not that bad. So this is what happens here. You're finding that you have a triangle that can have, with A, B, and C. C was 16, wasn't it? 16, 32. This one at B is 52.41. But the other angle that also has the same exact sine value is 180 minus the 52.41. Okay. That's what we call a reference angle. So when you subtract that out, this is still 16, 32. This is 92 down here. This was over here as well. When I subtract that out, that gives me 27.59. I always go two decimals. Okay. So what happens now is by showing that you have two possible triangles with that single acute angle, because one of the other angles could be obtuse or the other one could be acute. Now you're just solving two problems. You solve for A here, you solve for A here, using the law of sines again. In order to work with A, what's 52 and 16? 68. Subtract that from 180, that'll give you angle A. Find little a. You do the same thing here to find little a. Okay. You wind up with this is 111.59. This one is 36.41. I'm just using the sum of the interior angles of a triangle being 180 degrees to get those angles. And now I can get use my law of sines. And it's going to give me two possible side lengths for A. So whenever you have this, what they call the ambiguous case, it's the case where you wind up with two possible triangles. Once you solve the law for the first angle, you take that angle, draw a triangle, you'll solve for the other side. But in the other possible angle would be its reference. All that means is you're finding what that angle would be in the second quadrant by taking 180 degrees and subtracting it. It's not that bad, it's just I just like okay. Make sure your name's on the bookwork, send that up. We're going to we'll do a couple more of these here in a little bit. Yes, ma'am? No, because I'm going to assign more problems off of that over the weekend. Because I'm going to talk about now how you do areas and go off of that. Okay? I know that some of you guys were trying to use work with the areas of a triangle by doing the good old-fashioned 1/2 base times height, and you were given out these weird angles. You were trying to draw that in and use the law of sines and all that other stuff. Go from there. It's fine. It's nasty. It's ugly. It's no fun. But there's an easier way. It's math. There's always an easier way to do something. For example,
Like answer key.
what does that stand for? Side angle side. So when you have a side angle side, that meant somewhere in the triangle, you had a side, an included angle, and another side. Do you agree?
Yeah.
That's what that would look like. So when you're working with the area of a triangle, if you are given the side, angle, and a side, all you have to do is the following. The area of the triangle is 1/2 the side times the side times the sine of the angle. Really?
Wow.
So the area of this triangle would be 1/2 8 times 7 times the sine of 34. And there's your area of the triangle.
I got that.
Works for every single triangle. In the book, they showed you those 3 different formulas with all the different lettering. Who cares? Side, if it's side angle side, all you have to do is just multiply it out. It'll work every time. Does that make sense?
Yeah. Wait, what was that?
Are you going to use problems where you don't have a side angle side?
Yes, there's one of them on that worksheet right away.
Yeah, number 19.
What you have to do in that one is find the other side. How do you do that? Law of sines. So in some cases, you have to use the law of sines to get to that other side to make it work. Does that make sense? Yeah. All you have to worry about, and I think it's, what number is it, 19? Like on 19,
How do you find the other side?
law of sines.
I don't know. Oh, you need it. Don't you have to find other angles? Me and Jack's calculators both just that. That doesn't make
Yeah,
sense.
we get it right here.
He's just a big teddy bear. It's okay. He's just a big teddy bear.
Here's blank.
I just
Put your feet down.
here. I have that.
Again, when you're setting this one up, we have to first of all just take a quick glance. Is 95, what's that? 19. It's on the 13.5 side. When you're looking at this one here, 95, is it acute or obtuse?
It's obtuse.
It's obtuse. Is 250 bigger than 100?
Yeah.
So we know we have a triangle. It's gonna work.
It looks like a triangle to me.
So what we're gonna do is just take the sine of 95 is to 250, and we're gonna solve for b.
Yeah, that's what it says.
Once you get to there, then you can figure out what a is. Then you can figure out what that other side, the little a, would be by going around. You have to use law of sines a couple of times to get there. Does that make sense? Once you get that, once you find out, well, actually you don't even need to find the other side. Once you find out what angle B is, you subtract it out from 180, and that'll give you angle A, and then just go from there. Whatever it is. Okay? It should be relatively straightforward. Now, the other thing on this worksheet that I forgot to mention, on the 13.1 stuff, I want you guys to take a quick look at the 7 through 14. I honestly don't care if you know how to press buttons. I really don't. Yay, you can press buttons. Woo. The tangent of 5 degrees is,
I couldn't
who
find
cares?
Oh, yeah.
Here's what I want you to be able to do. And to be honest with you, I should have said don't do those. So I don't care about those numbers. I really don't. What I care about is the following. Cosecant of theta is 12 over 5 in a right triangle. Solve for all parts.
What number is that?
I'm just making this up.
13.
That's absolutely.
Okay? What I'm saying here is, I'm going to give you something more along the lines of that. The cosecant of theta is 12 over 5. Solve for everything else. Now, cosecant is the inverse of what trigon?
Secant, cosine.
Sine.
Sine.
Okay? So what happens then, it's the inverse of sine. If I pick an angle that's not the right angle to be theta, 12 is playing the role of what? The hypotenuse, adjacent, or opposite?
Hypotenuse. Opposite.
It is the hypotenuse.
How?
What does the 5 go? Bless you.
Opposite.
It's the opposite, so it goes here. Now what do you do to find that missing side length? Pythagorean theorem.
13.
And then what do you, it's not 13.
It's not.
It's
I thought
not.
it was a triple.
Yeah,
It's
that's what I
like
did.
13 is the hypotenuse. Has to be the hypotenuse. Because that's not the hypotenuse.
That's
yet.
why I chose those numbers.
Or if I just hurt myself.
That's okay.
I killed
Now
it.
from here,
I killed it in coffee.
if it was tangent or cotangent, you'd be all right. Now, in this case here, how do you again solve for theta? What button do you have to press to find theta in this case?
Enter.
Okay. Yes, you have to hit enter. After you press the, all right, what's the second button you have to press?
Second button. Sine.
Second.
Sine.
On.
9. It would be 9.
On. That'd be the first, technically.
What's this? What's the first button you have to press?
Sine.
On button.
Tell what? Yeah, I'm messing everything up.
You guys are, all right.
I'm saying
Second sign, right?
Murph, after
Assuming your calculator is already turned on, what is the next button you have? What's the first button you press?
Second.
What's the next button?
Sign.
Make sure you're in.
I've been saying.
Mode.
Wait,
There's
where's
always
result
one.
for Murph?
You wind up with that, okay? And then I'll give you theta, subtract it out from 180, get the other angle, use Pythagorean theorem to find the missing side. That's the kind of stuff that I would ask that you guys are able to do via inverse trig ops for right now. When we get further along, we'll start, when we get into radians and things of that nature in the unit circle, they tend to hold more of an importance, especially when we get into chapter 14, where we're solving equations using inverse trig functions. It's exciting.
What number was it?
I don't know his name.
31.
All I'm saying,
Similar to.
nothing.
Nothing.
Because in there it says, what is the cosecant of 13 degrees? Who
Yeah, how do you
cares?
do that?
There's a long way of doing it. Who cares?
We don't have to do it.
No, I want you to be able to do this.
So we don't have to do 7 to 14.
You just said that.
Can you guys hear me?
No. What?
Obviously you can't if you answer me.
We're gonna say that. Oh, they're gullible. Wait, so we should cross off 7 to 14?
No, just don't.
We already did that. I just don't think I did.
Are there any other questions on the 13.1 side of this worksheet that you guys want to double check?
No.
I can bring them out if you want.
Yeah, Murph, I have a question.
Yes, sir.
For some reason I'm just struggling with 15.
On
I don't know
13.1?
why. I feel
Do we
silly.
have to turn this in at some point?
have to do that.
Mr. Murphy?
Yeah. It's a right triangle.
Yeah, we did. Yeah.
When you're given the right triangle, if that's 46, that means this is 44,
Yeah.
and this is 8.
Yeah.
So if I'm starting up here,
So is it just sine 24 over 8 equals 8 over... Wait.
hold on, you're making it tougher than you need to. Just pick the given angle. The given angle is 46, correct?
Okay.
8 is your adjacent.
Yeah.
So the cosine
Oh, yeah.
of 46 is 8 over your hypotenuse.
Yeah.
Okay? The tangent of 46 is your opposite over 8.
Yeah.
To solve for your hypotenuse, do you multiply by 8 or do you have to divide by the cosine?
Divide by...
Good. So your hypotenuse,
That's what I did wrong. I was dividing by 8 for some reason.
there's your problem.
Yeah.
And then here you just have to multiply 8 times the tangent.
Alright. I was just...
Don't try and do it straight off the diagram. Take 2 seconds and draw that out.
I did draw this right. I drew.
Did you label it?
Yeah.
Oh, okay. Math is hard.
All I did was divide this. I divided each side by 8.
All right, I've got a very profound statement for you. Some of you might have heard this. Every time you do a push-up, you're bench pressing the earth.
Let's see you do a push-up.
Only if you're on
Yeah,
stand.
Mr. Murphy.
I can do a one push-up.
Yeah, only if you're in the southern hemisphere though.
And jokes suck.
Well done. I'm sorry, no, that was good. Sorry. As his soul is just crushed. It's, I shouldn't encourage it. I'm sorry.
Sorry.
Go ahead and finish this out.